Okay, sometimes in statistics you can encounter some extreme values in a data set. Hey, hey. Okay, sometimes you can encounter some extreme values. Those extreme values can be too small or too large as compared to most of the data set. Okay, now in statistics, such kind of values, we call them outliers. Okay, like for example, in this class, generally the class average will be at least 70%. That's the class average. Okay, at least 70%. So if you write a test and somebody gets 20%, that's most likely to be a what? An outlier in this class. Yes, if the class average can be as high as 70%, you write the test, you get 30% or you get 40%, it can be an outlier. Your mark can be an outlier. Now, if your mark is an outlier, like in this class here, it's a sign that something is wrong with you now. Okay? Yes. Okay, generally, it cannot be, in this class, it cannot be too high, but it can be what? Too low for this class. Okay, even if someone can get 98%, there is a probability that, which is almost 100%, that somebody might have 85% or someone might have 90%. So in that case, the highest mark may not be a what? An outlier. Are you following what I'm saying? But if you write a very challenging test, someone gets 98%, then probably the second highest may be 70%. In that case, the highest mark can be an outlier, which means the class average will go below what? 70%. You following what I'm saying? Now, whenever you've got a data set, you cannot make an assumption by just inspecting or looking at the data set and say this value is an outlier. That's not how it's done in advanced analysis. You have to do some kind of testing that a specific value is what? Is an outlier. Okay, so according to your curriculum now, you're supposed to know how to identify outliers in a data set. The way that you can identify the outlier, the procedure works as follows. First, you need to determine your median. So let me just calibrate my board. Okay, please just pay attention carefully. So if you want to identify outliers, okay, you need to determine your two quartiles. That is your lower quartile and your upper quartile. Okay, so what that means is you need to determine your Q2. If you are going to do it manually, if you don't have the calculator, which I told some of you to buy, in fact most of you, then you have to do it manually. Okay, I hope today you're also doing it manually if you don't have the calculator. We're doing it manually as well, isn't it? Shame. Right. So Q3 and Q1. Right. So if you don't have the calculator which can determine the quartiles for you, then you have to do it manually. If the data set is not arranged in order, you start by arranging it yourself, then you determine your Q2, your Q1, and your Q3. So normally it's always wise to determine the median first, because the median divides the data set into two halves. But you have to arrange the data set if you are doing it manually, which is not necessary anymore because of the calculator, which you must get if you don't get. Okay? So you must get your Q1, then your Q3. Then after that, you need to determine the interquartile range, which is equal to Q3 minus Q1. Okay? Then, now, there is a well-known interval which was proven by statisticians that this interval, if a value in a data set is outside the interval, then it may be a what? It will be an outlier. Now that interval, it has got a lower limit which is equal to Q1 minus 1,5 times IQR. That will be the minimum. Then the maximum will be Q3 plus 1,5 times IQR. So all you have to do, determine the lower quarter, the upper quarter, find the interquartile range. If you have got a data set, then subtract the product of 1,5 times the interquartile range from the lower quartile. You do the same for the upper quartile, but you have to add now the product of 1,5 times the interquartile range. Then you get any interval. Okay? So this will be the lower limit, that will be the upper limit. Then you identify within your data set if there is any value or if there are values that are outside. When you say outside, you're saying they are less than that difference or they are more than that difference. Then you can say the value is an outlier. You don't do it by inspection. Okay? You have to do that test. Okay? So, just to summarize this. If any value in a data set is outside this interval, that is Q1 minus 1,5 times the interquartile range and Q3 plus 1,5 times the interquartile range, that value is considered an outlier. Okay? And please remember I told you that in real life, when you are doing data analysis, if there are too many values that are outliers, you might have to redo whatever experiment you did or survey to collect that data. Because it means the data set has got a lot of exaggerations. You cannot make a decision based on it. Okay? So it's always better to have no outliers or just a few outliers. Okay? Sometimes outliers can also be eliminated when you are doing analysis. You discard them because they exaggerate or whatever you'll be dealing with. Actually, outliers have got an impact on the mean of the data set. They've got a strong influence on the mean of a data set. That's why the mean is not a very good measure of central tendency, because the mean is affected by outliers. It's also affected by the skewness of the data set. Okay, the median, generally the median is very robust. Okay, that word I don't like to use it for high school, right? But the median has got some resilience in terms of its influence, or rather, in terms of it being influenced by outliers. It's not easily influenced by outliers. So the median is a better measure of central tendency as compared to the mean. Right? Okay. Any question? This is very simple. It's not that challenging. Is there any question there? All right. If you don't have a question there, let's move on to a quick example. Not this one. Okay, I'm going to bring in. Okay. All right. Let's enter the data set in our calculators. All right, so I've entered my data set Then you press AC as always. Okay. Now I'm going to retrieve Q1 and Q3. Okay, because I need those two. If I want to determine whether there's a value in there, there's a value which is an outlier or not. Okay, so go to shift, then 1, then you go to number 6, then I just need Q1 and Q3. Okay, on my calculator it's number 6. On my calculator it's there.
You don't have.
No, you don't have. Right. So Q1 is 2.5. Okay. Then let's retrieve Q3. You see this? So that's number 6 there. If you don't have it, it's not my fault. Then number 5. So we have got 9 here. So Q3, which is equal to 9. Can I have your attention? Can you pay attention, please? So the interquartile range, IQR, is going to be equal to 9 minus 2.5, then this will give us 6.5. That's the interquartile range. Now, if we want to determine whether a value is an outlier or not, we need to determine two values. First value is Q1 minus 1.5 times the interquartile range. So this will be 2.5 minus 1.5 times 6.5. What answer do you get? Huh? 2.5 minus 1.5 times 6.5. Minus 7.25. That's the lower limit, right? Then the upper limit will be Q3 plus 1.5 times the interquartile range. Okay, so the interquartile range is 6.5. So this will be 9 plus 1.5 times 6.5. What answer do you get? 9 plus 1.5 times 6.5. Huh? What? 18.75. So what this means is, if a value is outside this interval, if a value is outside this interval here, then it's an outlier. Okay? If a value is outside that interval, then it's an outlier. So what you do, you just go to your data set, the original data set. We don't have any negative value. Okay, so let's just check the ones that are outliers. Remember, our interval is from minus 7.25 up to 18.75. So, is 1 an outlier? No. Is 5 an outlier? No. 9 no, 3 no, 12 no, 4 no. All these are not outliers. Okay? But this one now, 20 is an outlier. And also what? 90. So our two answers here are going to be 20 and 90. Those two are going to be outliers. Okay. Now you may, if you've done it by inspection, I think the only answer that you probably might have got maybe was that 90, because it's too far away from the rest of the data set. Okay, in that case, you might not have been able to identify 20 as an outlier. That's why you need to use this test in terms of that interval. Okay, so if you've got the calculator, you get your Q1, your Q3 quickly, determine your interquartile range, then find your lower limit and your upper limit, then go back to the data set, identify a value or values that are outside this interval, and then you are done. Okay, so finding outliers is a very simple thing.